folks, welcome back to physics. In this video, you're going to learn about velocity time graphs. By the end of this video, you will be able to construct velocity versus time graphs. So we're going to go ahead and jump in with an example. And the reason I'm going to do this is because you guys already really have seen how these graphs are constructed. So velocity time graphs are just like position time graphs, but on your y-axis, you show velocity instead of position. So what I'm going to do is I'm going to start by just drawing out our coordinate axes. So here is my x-axis, and here is my, excuse me there guys, here is my y-axis. And I'm going to label them the way that they should be labeled. So our x-axis, like in our position time graph, is going to measure time in seconds. And then our y-axis is going to measure velocity. And our units for that are, of course, meters per second. And I'm going to give my graph a title. So my graph is going to show me velocity, which is my independent variable. It's the thing that's changing. Or sorry, that's my dependent variable, the thing that I'm measuring. So velocity, again, my dependent variable, my y-axis, versus time, which is my independent variable, which I put on my x-axis. So my graph is set up, and this is going to be what you do for any velocity time graph. So you don't even really have to think about any data to get these three things correct. The axis label for the x-axis, the axis label for the y-axis, and the title. So now that we have that, let's go ahead and move into example 1. Vin walks forward at 10 meters per second for 7 seconds, then walks backwards at 2 meters per second for 3 seconds. Draw her velocity time graph. So I'm going to go ahead and construct my table. So we've got time in seconds, and we've got velocity in meters per second. That's that -1 here. It's a little hard to see. So we start at 0 seconds. And for the first 7 seconds, she's walking forward. So we know that we're going to go from 0 to 7. And then we have a further 3 seconds in our problem. And so we're going to go all the way up 3 more seconds to 10. So 8, 9, and 10 seconds. Next, we can put in her velocities. So for the first 7 seconds, Vin is walking at 10 meters per second. So 0, she's at 10, 1, 2, 3, 4, 5, 6, and 7 seconds she is spending walking at 10 meters per second. Then, suddenly, she's walking backwards at 2 meters per second for 3 seconds. So we've got 2, 2, and 2. Now I'm not quite done because there's something very important that I'm missing, and that is directions. So we'll see Vin starts out walking forwards. So her velocity for those first 7 seconds is going to stay positive. But then she's moving backwards for our last 3 seconds. So those 2s are actually going to be -2s because she's walking in the negative direction. So I have all the information I need now to construct my graph. So let me go ahead and do that. And I'm going to start by labeling my axes. I'm just going to go ahead and label every 2 seconds. So 2, 4, 6, 8, and 10 seconds. And I'm going to do the same on my y-axis. I have 2, 4, 6, 8, and 10 meters per second. And I've got my -2, -4, -6, -8, and -10 meters per second on my y-axis as well, because I can move both backwards and forwards. So for our first 10 seconds, first 7 seconds, we're moving at 10 meters per second. So let me go ahead and put that in my graph. So 1, 2, 3, 4, 5, 6, and 7 seconds, I'm going at 10 meters per second. And guys, you'll see here, I started at 0, and I went to 7, instead of just drawing, so that meant I had to draw 8 dots. So just keep in mind, you'll have more dots than you have seconds. So then at our 8th second, Vin starts going backwards at -2 meters per second. And we're going to say that it is right after that 7th second that she turns back and goes that -2 meters per second. So it's going to be that immediate switch. And so at our 7-second mark, we're actually going to also draw a dot at -2 meters per second. And the reason I'm doing that is to represent the fact that her velocity changes almost instantaneously. So we're not going to worry about the time it takes her to turn around and slow down. So now I've connected my dots and I have this nice, smooth, easy graph. So there you have it, guys. Here is a velocity versus time graph. Let's do one more. And I'm going to go a little quicker this time. So again, I'm going to go ahead and draw my coordinate axes. Like so. So, Kelsier is going to walk forward at 2 meters per second. I'm going to make that yellow instead, for 1 second. Then he'll stand still for 2 seconds, and then run backwards at 5 meters per second for 2 seconds. So we're going to draw Kelsier's velocity time graph. So let's go ahead and again label our axes. So we've got time in seconds. We've got velocity in meters per second. And we're going to say that our graph is showing me velocity versus time. Now I can again construct my table. So I have my time and I have my velocity. So again, I start at 0 and go to 1 second. And for that period of time, I'm traveling at 2 meters per second. Then for 2 more seconds, so my 2nd second and my 3rd second, Kelsier is going to stand still. So his velocity will be 0. Because that's what standing still means, right? You're not moving. Then he'll run backwards at 5 meters per second for 2 seconds. So my 4th second and my 5th second, he is going to be moving at -5 meters per second since he has changed direction. So let's go ahead and turn this into a nice graph. So we've got 5 seconds to worry about. So we've got our 1, 2, 3, 4, and 5 seconds. And we can do the same on our y-axis. We've got 2, 4, 6 meters per second, -2, -4, and -6 meters per second. And I can go ahead and mark my graph. So at 0, I'm going to put my dot at 2 meters per second. I'm going to do the same at 1. And then, remember, I'm going to suddenly stop at that 1st second mark. So I'm kind of moving and not moving almost at the same time. And again, I'm going to show that abruptness by putting a dot at my 1st second. And at 2 and 3, I'm also going to put dots at 0 to represent myself standing still. Then I'm going to do the same thing I did at my 1st second, and I'm going to go straight down at my 3rd second to -5. And again, that's just to represent my super quick change in motion. And at my 4th and 5th second, I'm going to also add dots at -5. So let's go ahead and connect the dots. And there you go, Kelsier's velocity versus time graph. And again, guys, the tricky thing here is going to be these moments where he is switching speeds very, very quickly, immediately. So you have to represent that with these vertical lines, which is something you may not be used to doing. So let's go ahead and talk about some takeaways. First of all, velocity time graphs are used to show your change in velocity over time. So we're showing your velocity on the y-axis and showing how it changes over time, which is our x-axis, which goes into our second takeaway that time is going to be on the x-axis and velocity is going to be on the y-axis. And finally, the direction you move in on the y-axis, so whether you go up or down, is going to depend on the direction you're moving in. And more specifically, I'm actually going to cross off the word direction here, the sign on the y-axis. So whether you're positive or negative on the y-axis is going to depend on whether you're moving forwards or backwards. So guys, you have now learned how to construct velocity time graphs. Go ahead and see if you can do this on your own. Best of luck and happy solving.